Welcome students. In this module, we are going to discuss problems in direct step method. First, we will see in single step method one problem. Then we will go for two-step method. Then we will solve some problem in standard step method also. Okay. First, in single step method, as we know, in single step method, formula is directly given. Just we have to substitute the entire values in formulas. First, read up, if you read up the problem, a rectangular channel of 1.5 meter wide carries a discharge of 2 meter cube per second. 2 meter cube per second. Discharge value is given as 2 m cube per second and width is given as 1.5 meter. Bed slope is 0.0004. Bed slope S0 value also given. If depth of at uniform condition, that means uniform flow condition, that happens when it happens means at not in upstream side, in that means y1 value is given as 0.75 and afflux value of 0.25 meter. That means at nearer to the dam, y2 value is nothing but addition of 0.75 and 0.25. If you add these two values, then you will get y2 value. Then calculate the length of backwater curve. Take n is equal to 0.14. Now we will draw a diagram based on this. If we mark all data in the diagram, then we will get a clear picture about this problem. Okay. Q value is given as 2 m cube per second. Breadth is given as 1.5 meter. Afflux is given as 0.25. Yn value is given as 0.75 meter. If I know y1 and afflux, then I calculate y2 is equal to sum of y1 plus afflux. If I calculate these values, then I will get y2 is equal to 1 meter. After calculating y1 and y2, what I am going to do is just I am writing that formula. That means length of backwater is equal to E2 minus E1 divided by S0 minus SE. S0 value is given as 0.0004. SE is not given. E1 I can calculate, if I know y1 and y2, then I calculate A1. Area at 1 is equal to y1 into B. Like that I can calculate A2 equal to y2 into B. Y1 value is 0.75, B is equal to 0.25. 0.5. Like that here 1 into 1.5. I know discharge value, then I calculate V1 value. V1 is equal to Q divided by A1. Like that V2 is equal to Q divided by A2. If I calculate, I will get V1 is equal to 1.33 meter per second. V2 is equal to 1.78 meter per second. Okay. Once I calculate V1 and V2, what I am going to do is specific. I have to calculate specific energy at 1. Specific energy at 1 is equal to Y1 plus V1 square divided by 2G. I know Y1 value. I know V1 value also I know. V1 is equal to 1.33 meter per second. Like that V2 is equal to 1.78 meter per second. If I substitute, then I will get E1 value as 1.091. If I substitute E2 is equal to Y2 plus V2 square by 2G, then I will get 0.91. Okay, sorry, I just wrongly wrote answer. This value will be is equal to 0.91 meter. This value is equal to 1.091 meter. Here E2 minus E1 or E1 minus E2, that is no problem. What we need is magnitude. Okay, so if this term becomes minus, we can take it as positive. S not given, so now I calculated E1, now I calculated E2. These three values are we know. Only thing we don't know is SE. We have to calculate that SE by using average parameters as in as we did in dynamic equation of gradually varying flow. So for SE, what I am going to do is I have to calculate y average y1 plus y2 by 2. I have to calculate A average. Then I have to calculate P average. This value is we know 0.75. Y average is nothing but 0.75 plus 1 by 2. That means 1.75 by 2. Okay. 1.75 is nothing but 0.875 meter. A average is equal to breadth 1.5 times 0.875 meter. Like that, P average is equal to 0.875 into 2 plus 1.5, because depth plus width plus depth, this concept. So by using A average and P average, I have to calculate M average. M average is nothing but A average divided by P average. If I substitute these values, I'll get M average is equal to 0.404 meter. Okay, M average is equal to 0.404 meter. If I calculate M average, then what I have to do is I have to calculate V average. After calculating V average, I know formula. Here Manning's coefficient is given in problem 1 by n. N value is given as 0.014 into M average. I calculated M average. M average value is nothing but 0.404 power 2 by 3 into SE power half. Okay, I know V average value. V average value I can calculate V1 plus V2 by 2. If I average V1 and V2, I'll get V1. If now I know this value and this value. If I substitute, then I will get SE is equal to what I will get as SE is 1.524 into 10 power minus 3. Okay, after calculating this SE, if I substitute this SE in this formula, after substituting everything, I will get length of backwater is equal to 161.03 meter. Okay, students, just try. I gave all values, so all values are correct only. So if you solve, you will get a proper idea about this single step method. Now we will go and discuss about two-step method. In this problem, they are given as we are going to solve a two-step method, because in question itself they mentioned as two-step. In a rectangular channel of width is given as 2 meter. Depth is 1.2 meter at one section and 1.4 meter at another section. If discharge is equal to 6 meter cube per second, Manning's coefficient equal to 0.015, then calculate the distance between these two sections. What they given in question is, at one section depth is 1.2 meter, at another section depth is 1.4 meter. They are asking distance between these two depths. Okay, what is this value? This is length of backwater. They are asking this length of backwater. How I am going to calculate this length of backwater? That is very simple one. For two-step method, first we have to draw tabulation, because by using the tabulation only we can simply calculate the values. First we have to split this entire section into S1, S2. Here depth is 1.2, here depth is 1.4, then this average value will be 1.3 meter. So I am splitting depth section 1 as 1.2 to 1.3, then second section as 1.3 to 1.4. Now let's draw diagram. Next we draw tabulations. For two steps, I am splitting entire depth into two sections, 1.2 meter to 1.3 meter, 1.3 meter to 1.4 meter. First step is we have to calculate average depth. So average of these two, 1.2 plus 1.3 divided by 2 is 1.25. Like that, for this average is 1.35. Then A average. A average is nothing but, I wrote a formula here, breadth times Y average. Breadth value is given as 2 meter. So this is 2 into 1.25, that will be 2.5. This is 2 into 1.35. This is 2.75. Then P average is nothing but 2 times Y average plus breadth. Breadth value is, we know breadth value is equal to 2 meter. So P average is equal to, for this section 4.5, for this section 4.7. I know M average. M average is nothing but ratio of A average and P average. This value is equal to this divided by this. Like that, this value is equal to this divided by this. So this value will get as 0.56. This value is 0.57. Then V average. Discharge is given as 6 m cube per second. So I know what is discharge. Then I know what is the value of A average. By using discharge and A average, I calculate V average is equal to 2.4 here 2.22. Then I know fruit number. For fruit number formula, fruit number square equal to V average square divided by G into Y average. I know what is V average. G value is 9.81. I know what is Y average. By using this V average and using this Y average, I can calculate fruit number square is equal to 0.47 here. For this case, I have to use this Y average and this Y average and this V average. This V average square divided by G times G 9.8 1 times 1.35. If I substitute, I'll get this value is 0.37. Then 1 minus Fn square. I know Fn square. 1 minus 0.47 square is equal to 0.53. Like that, 1 minus 0.37 square is equal to 0.63. Now I calculated first top portions. Then I am going to calculate about bottom portions. In second part of the tabulation, S0 is nothing but bed slope. Its value is given as 0.002. I have to calculate SE. How I can calculate SE? SE is nothing but how I can calculate means SE can be calculated as in direct step. I mean, that means dynamic in dynamic equation of gradual varying flow. We calculated using average parameter. Same thing we are using here. Here Chassis constant is not given. Manning's coefficient is given. So we have to use Manning's formula. V average. We know for this case I know what is V average. Like that, for this case I know what is V average. For example, this term I am calculating for model calculation. For that term, for that case, for first section, average velocity is 2.4. So 2.4 equal to 1 divided by n. N value is nothing but 0.015. M average for first section is equal to M average for first section is equal to 0.56 power 2 by 3 n SE power half. If I calculate this SE, that will be this value. That SE value is equal to, for this section, 2.808 into 10 power minus 3. Like that, for this case 2 point, okay, here this case 2.346 into 10 power minus 3. Then I have to calculate S0 minus SE. This value will be is equal to 0.808 into 10 power minus 3. Here minus sign will come. We don't bother about that. Like that, here minus 0.346 into 10 power minus 6. Just simply subtracting this value from this. Then for dx by dy, I know in first part of the tabulation I calculated 1 minus Fn square for this section, 1 minus Fn square for this section. For this section I am doing calculation. 1 minus Fn square is equal to 0.53 divided by S0 minus SE value is equal to 0.808 into 10 power minus 3. Here I calculated. If I substitute these values, then I will get dx by dy for this section is equal to minus 655.94. Like this, for this section I will if I calculate, I will get a value of 1820.81. Okay. dy is nothing but difference between these two depths. Difference between these two is nothing but 1.3 minus 1.2, that is 0.1. Like that, 1.4 minus 1.3, that will be also 0.1. If I know everything, then I can calculate what is dx. Dx is nothing but how I can calculate dx is nothing but dx by dy into dy. If I multiply these two values, then I will get dx value 65.59. Like that, this value will become 247 point, sorry, 182.081. If I know these two dx's, if I add, that is length of backwater. Length of backwater is equal to dx1 plus dx2. dx1 value is 65.59, dx2 value is 182.081. If I add, then I will get length of backwater is equal to 247.67 meter. With this, I completed problem in two-step method. Now we will go for direct step method. Okay, in direct step method, standard step method. Okay, standard step method for non-prismatic channel. Next, see a problem. A trapezoidal channel with a bed width of 10 meter and side slope of 1.5 horizontal is 1 vertical carries a discharge of 80 meter cube per second. If S0 is nothing but bed slope is equal to 0.002, Manning's coefficient n is equal to 0.015, then calculate the depth at 250 meter, 500 meter from the upstream side. Okay. Depth at upstream is 10 meter. Depth at upstream is given as 10 meter. Use standard step method. Now, what they asked, just I am erasing this data. You note down and you just follow the problems. There, actually, here value is given as 10 meter. From 250 meter, what is depth? From 500 meter, what is depth? They are asking these two values. How we can calculate these two values is very simple. Y250 will be 50 is equal to 10 minus dy by dx into 250. That means depth, distance between these two. Surely y250 value will be less than 10. Like that, y500 is equal to 10 minus dy by dx times 500. Here only unknown is this dy by dx. dy by dx is nothing but we already calculated the dy by dx. That means that is nothing but dynamic equation of gradual varying flow. If we know how to calculate dy by dx and if we substitute dy by dx here, then we will get y250 and y500. Now let's discuss how to calculate dy by dx. This is a given trapezoidal section for the problem. What we are going to calculate is, we have to calculate first area and perimeter. Discharge is given. Depth is given as 10 meter because on upstream side depth is given as 10 meter. Bed width is given as 10 meter. Here slope is given as 1.5 times the horizontal is 1 time vertical. That means for 10, if I am taking same slope here, if this value is 10, surely this value will become 15. We already discussed so many times this in previous module itself. Okay, so area is equal to area of this triangle, that is nothing but half into 10 into 5, 15 plus this rectangle is 10 into 10 plus again triangle half into 15 into 10. If I solve, area will be is equal to 250 meter square. Okay, like that. Perimeter is nothing but this length plus this length plus this length. This length can be calculated using Pythagoras theorem. Root of 15 square plus 10 square, root of 15 square plus 10 square plus 10 plus root of 15 square plus 10 square, that will be is equal to 46.05. If I know P and A, then I can easily calculate R. R is nothing but area divided by perimeter. That value will become 5.43. I know discharge is equal to area times velocity. Here Manning's formula is given 1 by n r power r or m. Okay, I can use any term into m power 2 by 3 SE power half. SE means SE. Here n value is given as 0.015. Area value is 1 as a 250. M value we calculated as this. So Q value is this. If I solve, I'll get SE. SE is equal to 2.414 into 10 power minus 6. If I calculate SE, then everything will become simple. Okay. Then dy by dx is equal to S naught minus SE divided by 1 minus fruit number square. I know what is SE, S naught, SE now only we calculated as 2.414 into 10 power minus 6. But Fn is not given. Fn is very simple thing. Fn is nothing but velocity, okay, where V average square divided by G times Y. Okay, I know what is velocity. Velocity I can calculate using Manning's formula. That is nothing but 1 by n m power 2 by 3 I power half. Okay, I is nothing but bed slope. If I substitute bed slope value here and m value, I will get V average. That V average value will be equal to 0.32. If I substitute this 0.32 here, then the dy by dx will be equal to 2 into 10 power minus 3. So dy by dx value will become equal to dy by 2 into 10 power minus 3. Then y at 250 will be is equal to 10 minus 250 into 2 into 10 power minus 3. If I substitute, I will get 9.5 meter. Like that, y at 500 is equal to 10 minus 500 into 2 into 10 power minus, that means bed slope. If I substitute, I will get 9 meter. So this is the problem which we solved using standard step method. So with this, we are completing unit 2. Thank you.